The next reaction we're going to look at is the oxidation of alcohols. Now, oxidation is very similar in terms of process to combustion. We're basically talking about adding oxygen to a substance. However, it occurs much more slowly than combustion and with much less energy being produced. Okay, so you can see the equation for oxidation of alcohols on the board. When an alcohol is oxidized using an oxidizing agent, so when we add oxygen to an alcohol using an oxidizing agent, then our products are carboxylic acids and water. So if you oxidize an alcohol, you get a carboxylic acid. There's an example equation on the board. Okay, so ethanol, if you add an oxidizing agent, and an oxidizing agent at GCSE is written in a symbol equation by putting an O in between square brackets, as you can see in the equation on the board. Okay, we get ethanoic acid and we get water. You don't need to know the formulas of the oxidizing agents. Okay, you can just put the O in the square brackets and add as many O's as you need to add, in this case 2. Okay, so you do not need to be able to write a full equation for this until IB level. Okay, so in my test tubes, I have got 3 different alcohols. I've got methanol on the left, ethanol in the middle, and propanol on the right. And to those, I am going to add some of my oxidizing agent. My oxidizing agent is called potassium dichromate. And as you can see, it's a very bright orange colour. Okay, so it's a nice bright orange powder. Okay, and in order to oxidize this substance, I've added my oxidizing agent, which was my potassium dichromate. I also need to heat this in a water bath for a certain amount of time, normally around 15 to 20 minutes. Okay, without the heat, the reaction is too slow and therefore will not progress at a speed that is suitable for us to see. Okay, but I have made one earlier to save us some time. And you can see that when the reaction is complete, that the potassium dichromate in each case turns a green colour. Now, this is not to be mistaken for universal indicator. Okay, so this is not universal indicator. That is the potassium dichromate, which has turned green. Okay, obviously, if it were universal indicator, we would expect the colour to have turned not green, but red or orange, because what we are producing in each case is an acid, a carboxylic acid. Okay, so we have found that it has turned green because the oxidizing agent, when it works, turns green, not because it has become neutral. It's important that you can make that distinction. This process happens in everyday life as well. So although I told you that we need heat in order for this process to happen and an oxidizing agent, that's just to make it happen quickly at a speed that we can actually measure. So even if you just leave an alcohol at room temperature and without an oxidizing agent, it will oxidize over time, but it will take several hours, possibly even days, for this to happen. And this happens with quite a lot of alcoholic beverages, particularly wine. So it is a common thing which comes up on television programs where you see that someone says that the wine has gone off or the wine has spoiled. Sometimes you might hear it referred to as the wine has turned to vinegar. This is because the main ingredient in wine, that is an alcohol, is ethanol, and the main ingredient in vinegar is ethanoic acid. So what actually happens when wine turns to vinegar is that the ethanol in the wine is oxidized to form ethanoic acid, which is why the wine starts to taste sour and unpleasant, because some ethanoic acid has been produced and that is not pleasant to drink.